finally going to dig into a computer that I have been waiting to play around with and experiment with for quite a while now. It's time to take a look at this Heathkit ET-3400 computer. Now, I picked this computer up last summer. I believe that I showed it in a pickups video, I want to say the end of last August 2021, and I've just been waiting to turn it on and do some stuff with it ever since then, but you know, things have gotten in the way. This computer is based on the Motorola 6800, yes, 6800 microprocessor. The system itself was released by Heathkit, in 1977. In kit form, it had an initial release price of $190, which in 2021 money is about $880. You could also purchase it fully assembled for, I want to say it was $240, which in 2021 is closer to $1,100. Yes, folks, computers used to be really expensive, and now they're just, disposable, throw them away as soon as you get them. It's kind of funny to think about the whole arc that things have taken. Now, this is a massively modifiable computer. It was designed for experimentation and learning. I mean, it has breadboards built right into it. It has places where you can tap into all the address lines, all the control signals, everything. It is meant to be a vehicle for experimentation. And that's exactly how I intend to use it. I am hoping to turn this into a series of videos where I'm going to perform a bunch of modifications on this system and make a bunch of my own additions. There are lots of projects that other people have done that can be found out on the internet. And I plan to add to that corpus of work. Now, kind of a funny story. Before I found this computer last summer, I had never actually heard of it. But as soon as I saw it, I knew that I had to have it. And then a little over a month ago, while I was shopping at a local store here in my area that I like called Surplus Gizmos, they had one there. I was very surprised. Now, the one that they had a price on it, but it sounded like they had talked themselves out of selling it, that they thought it was too cool of a thing and they were going to keep it. The one that they have is filthy. It was so dirty. And 2 of the 7-segment displays had been removed from it, and wires were run from the sockets where those displays had been down to the breadboard area, and there was some circuitry down there for I can't even begin to guess what purpose. But that really just underscores the way that this device was intended to be used. Just hack on it and do whatever you want and just, knock yourself out, kid. So I think with all that jibber jabber done, I think it's time to go ahead and dig into this thing. In a lot of ways, this Heathkit ET-3400 computer has a lot of similarities with the KIM-1. One big difference that is important for this video and for any follow-up videos that I may have is, as far as I'm aware, the only bespoke chip on this whole system is this ROM. And I'm not even really particularly concerned about that ROM chip, because in the documentation for this device that they provide to you, that this came as a kit, Heathkit after all, the documentation that they provide so you can actually put the thing together includes the full assembly and hex dump of the contents of this ROM. So even if this chip is bad or somehow I ruin it or whatever, it can with some effort be replaced. But still, okay, so there are a lot of similarities. 7-segment display readout, the phone style keyboard input with some shortcuts, tiny little bit of RAM. This has the 512 bytes of RAM. The ROM, I want to say, is 1K, but I'm not remembering now right off the top of my head. The other thing that's neat about this is everything is breadboarded in. So it's really easy to put some other expansions in here and just wire it into the bus. One of the things that's super easy to do is add a RAM expansion here and just wire it directly into the bus, and have some logic here to control when the RAM enables happen, and add however much RAM you want. One of the other expansions that was available, and this one will require some modifications to do this. You can connect through, there would be a pin header here, and you can connect to another device that is the same size as this, and you would set this on top of this other device that contains additional ROM, additional RAM, an RS-232 serial port, and with that added ROM, RAM, and external connectivity, you could connect this to a terminal and program on it in BASIC. Ooh, moving into the future. Otherwise, you're keying in the hex for assembly by hand, just like on the KIM-1. I believe that expansion also has a cassette tape interface, but I don't remember 100% for sure. And there are people who have created circuit boards to recreate that device using mostly modern parts. I think that it still needs a very specific vintage UART kind of chip. But as far as I'm aware, that's the only non-modern part required to rebuild that device. So because of that, I'm not afraid to turn this on. I was terrified to turn on the KIM-1 because if any magic smoke came out, that I would have had to cry myself to sleep. But with this, if any magic smoke comes out, I can replace a 6800 processor. I could probably replace these RAM chips. They'll probably cost me $30 a chip or something. I can replace any 74 series, logic chips. That's no big deal. So this is going to get turned on. But before that happens, the first step is going to be to disassemble it at least a little bit and check out the power supply. These things, like I said before, they came as kits. So the person who bought it is the person who put it together. And, who knows how talented that person was at the time when they put this thing together. When I open this up, it might look beautiful, like an artist put it together, or it might look like a trash fire, like I put it together. So I'm going to probably do a quick cut here and flip this over and start taking this apart, because I think all the screws for it are on the bottom, although there are some screws on the top. So anyway, take it apart, take a look inside, disconnect the power supply from it, check out the power supply to make sure it's giving off reasonable voltages and isn't going to just incinerate everything. I don't mind replacing a couple of chips if magic smoke comes out, but if it can be prevented if frying all of them can be prevented, I would like to take those, that little extra moment to err on the side of caution. All right, let's take this thing apart. So one thing back here that I think is kind of neat is there's Heath Company's contact information and a warning to unplug it before you open it up and potentially shock yourself. Have the original Heathkit sticker on the back, model number, serial number 6928. I don't know how many of these were sold, so I don't know if this is a low serial or not. No idea. Let's go ahead and just open this up. It looks like it has 8 of these nice flathead screws. I don't know that this is actually holding the case together. I think it's just these outer ones. I'm going to start using a new trick that I learned from a different channel. I'll put text on the screen right now to remind me what channel it is, because I can't think of that channel's name. He does a lot of good fixing up of all sorts of random stuff. But he puts all of his screws in an ice cube tray so that they can all stay nice and separated by what they were and not spill out all over the desk. I'm gonna guess that this should be a top lift off instead of the bottom lift off. Yes. Oh, wow. All right, so my clever plan about just disconnecting the power supply may not pan out. There are a lot of wires. 6 wires come off of... So this must be... I'm not sure what this must be. Well, let's have a look. What's in here? Ah, the fuse. And I can't quite tell. It looks... I'll pop it out. It looks like it... All right, now I'm not going to pop it out. I'm just going to look really closely at it. It looks intact, but I'm not 100% positive. All right. Okay, that looks good. Fuse is intact, which is a good sign. So I'm not going to need to dig around in here anymore, so I'm going to go ahead and just put this back together. Okay. Well, I have to say, looking at this, that this solder job looks really good. Far, far better than I would have done for sure. But I think to really get a good look at what's going on and see if I can sort anything out about this power supply issue, I'm gonna have to take this the rest of the way out, which I'm gonna assume means removing all these sundry hex head screws. This is the back of the keypad, so there's not anything hiding under there. I'm not sure what these little flathead screws might be for. And I don't know why it surprises me after I take the top off that what's on the other side is the thing that, you know, comes out through the big hole in the plastic that you can just see all of. So the one additional thing is you can see where the transformer connects through. This end goes through some diodes. So and then those come through here. This comes through the power switch, and then this is the rest of the power board. So it is not immediately obvious to me what I would want to desolder and check with a multimeter to be able to verify this power supply and not potentially, kill myself. Which would not make for great YouTube viewing. So what I might just do, because this does look really, really well put together, I think I'm going to just set this back in here and go on a wing and a prayer and hope that it just works. All right, so one I have solved one mystery. These 3 screws are holding this large breadboard in. If I can get on camera, are holding this large breadboard in. These. So if it doesn't come on, there is a large, really, really detailed troubleshooting section that goes on for pages and pages in the manual of what to do if various things aren't working and what things to check and very specific experiments to do to verify various components. So I think I'm going to set this back on the case and just go for broke. All right. So I've decided to start recording before I even plug it in, just in case. I did put the lid on just so that the direct power lines weren't exposed, so that I wouldn't potentially shock myself. I mean, accidents and random stuff happen, and I'm not as cavalier about poking around high voltage stuff as Adrian Black is, or some other folks. I'm a little more timid about it. All right, so let's see. Hopefully nothing happens when I plug it in. All right. Now, when I turn it on, it should take a little bit, and then this display should come to life. And nothing. Is this power strip turned on? No, the power strip's not turned on. That'll do it. All right. Let's turn the power strip on. All right. So now the power strip's turned on. And the standby light is on, so it is getting power. All right, let's go for broke. The LED's lit up. I believe you're supposed to hit reset. And it says CPU up, so thus far it is behaving exactly as it should, and that is pretty awesome. I am totally stoked about that. So I'm going to go grab, there's a couple of sample programs to input via all the typing on the keypad, and hoping that you don't, miskey somewhere along the way and have much sadness. I'm going to go grab, I'll probably pull that up on a tablet or something so that I can have it off to the side and look at it, and I'll key that in and see if a program actually runs. And then I think we'll call this good. Yay! All right, so I'm going to do the first test that they specify in the manual for this, which isn't even entering a program. It's basically just making sure that the display works and will display all the characters, and that the whole keypad works. So I'm going to go ahead and go through that. It says hit reset, exam, 0, 1, 2, 3, channel 4, 4, 5. Okay, that all looks good so far. Exam, 6, 7, 8, 9. Chan, A, B, B, B. Okay, so, oh, no, it did come up. All right, so the B key maybe needs some some love. All right. And then exam C, D, E, F. I think that's it. Yeah, that looks like it for that test. All right, so that looks good. The keypad is working, except the B key is maybe has some issues. I suspect that popping off that key and maybe cleaning it out and giving it a little deoxit will probably take care of that. Off camera, I popped the keycap off, tried to spray a little deoxit in. It may have helped some, but this B key is still marginal at best. I haven't screwed any of this back together, so I just flipped it around and looked to see if there was any issue with the two solder joints on the back of this key, and they both looked fine. And since this is part of a keyboard matrix, all of the other solder joints would be shared with some other keys, and all the other keys work perfectly. So I don't know what the issue is. I'm gonna have to dig into it maybe a little bit later. It'll require a little bit more surgery than I think I feel like doing tonight. But I did continue to look through the manual that came with this, and I found the shortest program that I can enter. It does unfortunately have a couple of B's in it, but I think it looks like maybe only 4. so maybe I'll get off easy and this won't be too painful. The program is only 36 bytes, and it's supposed to basically do just some cycling on the display. So I'm going to go ahead and try and enter this and run it, and hopefully it'll work. And we'll have a happy conclusion to this, and I won't have to do any other kind of debugging on it. And then in some future videos, I'm going to play around with this quite a bit more. I was very excited about this, and I'm super happy that it appears to be working fine, except the B key. So I'm still going to call that a win. And then naturally, the first nibble in the program is a B. All right, let's go ahead and go with this. Okay, so that should be it. Then I think if I understand what I read before, I need to just branch to address 0 and then branch again? No. I don't. No. I'm not sure what to do next. Oh, there it goes. Okay, so it's do, and then, so it's really dim, but it's cycling through all the things. Here, I'll pull in the zoom a little bit. So do 0, 0, 0, 0. And you can see it cycling through. All the excitement. So all of the LED segments appear to work, and yay! All right, that is great. So it works, and I could enter a 36-byte program without losing my mind and have it actually work. Yay! That turned out about as well as I possibly could have hoped. The only flaw with the machine that I was able to discover was the somewhat flaky B key. And after a while of using it, it seemed to work out a little bit better. Now, after entering that massive 36-byte program, I did find out that there is a much faster way to enter the program so that you don't continuously have to advance the memory address that where you're going to modify the data. Okay, all right, I'll do better next time. I hope to return to this in not too long. I'm not gonna do more programming by entering things by hand like that, so I'll have to figure out some way to wire up my own ROMs to it so that I can just write stuff to a ROM and execute it directly from the ROM. I want to try to write a couple little simple games to use the 7-segment displays and do some stuff like that, and then start doing some kinds of hardware add-ons. I don't know that I really want to hook up a terminal to it, which is the sort of the main add-on for this device. Added some I/O, RAM, and BASIC, and you would connect a terminal to it. I think that I want to try to cobble together some sort of composite output display to it and, go direct to the metal like that. I don't know. I haven't decided about that for sure. I have a ton of other ideas, so I'm definitely gonna have some fun with this device. So until then, remember to like and subscribe. Follow me on Twitter and on Instagram. I'll put links in the description below. Try to remember the good stuff.